Hi everyone, here's our math lesson for today. One of our followers asked me how to create this beating heart animation. Now, I'm doing this animation in Desmos graphing calculator, so you can follow along as I create this beating heart animation. The first important math lesson here is to understand the graph of a sine function. In our previous video, we have this crash course on the sine function, and we said that the form of a sine function is a times sine times the quantity b times the quantity x minus c plus d. In here, a is the amplitude or the height of the graph of the sine function. This b is very important as we create that beating heart animation, because this is the one that determines the frequency or the number of cycles from 0 to 2 pi, as we are going to see later on. We are not so much after this d in that heartbeat animation. So let's go back to the Desmos graphing calculator. So the first thing that we are going to do is we are going to graph sine ax. Let's start with a equals positive 1. So here's the graph at a equals positive 1. Now we said that the number of cycles for the period of 2 pi is the frequency of the graph. So from 0 to about 6.24, that is from 0 to 2 pi, we have one cycle here. Now, if I increase the number a, notice that there are more cycles in that span of 2 pi. Conversely, if I decrease, there is less cycles per period. And then if I go to negative, it's just reflected to the other side. I'm going to multiply this with pi so that I can have more cycles in the same period. And if I animate that, I can vary the value of a, then we have this moving graph. Next, how can we form a heart shape? We can form that heart shape if we are going to control the height of the wave. And I can do that by multiplying sine a pi x by certain constant. And I am interested with this shape because this shape can hopefully bound the height of our sine function. So what I'm going to do now is I'm going to multiply sine a pi x by this function, the quantity 3.3 minus x squared all raised to 1/2. And here is now the result. So this is the sine function. This is the multiplier that we have. If we multiply this sine a pi x by this expression where x varies depending on the location of the point, then we will have this shape. And let's see how the animation looks like. Now it looks like a circle. We do not see the heart shape yet. So what we are going to do is we are going to add a certain number to the existing height of the waves so that this part here would be higher, then this part here would be lower, so that we can form a heart shape. And we are going to use this one. So that if we combine that with our previous result, let's say you have this height plus the height of this green, then that would be a little bit here. This height here plus this green, when added, would be taller, and so on. So let's see now how it looks if I add this expression x raised to 2/3, which is this green graph, added to this blue graph. And here's now the result. Notice that this blue height plus this green height becomes this red height, and the same explanation for the rest of them. Now let's remove this blue and this green graphs. This shape is more like a heart shape now, and let's do the animation. Notice now that we have that shape of a beating heart that is shaped based on the height of the function. And we now have here this beating heart animation. So this Desmos graphing calculator is very good in exploring the graphs of different functions, and it has the ability to animate if you automate the value of some variables. So thank you very much, and I hope you find this interesting.